All right, the last leg of the marathon coming at you here. Let's see what we got. So now we're going to graph one of these things and do a whole lot of pieces of information. First, let's identify the vertex, which was actually addressed in one of our earlier videos. That would be at -3, 8 right here. My axis of symmetry is a vertical line that goes right through the middle of that vertex, which would be x equals -3. It's a line that comes down here like this. Nice little vertical line, x equals -3. I like to label them personally. Now, the x-intercepts are a little bit interesting because when you look at it, sometimes we get lucky and sometimes we don't. So let's just see what happens this time. My 1, 3, 5 pattern got multiplied by -2. So I'm going to go over 1, down 2, then over 1, down 1, 2, 3, 4, 5. Oops, must have messed that one up. That's 8. Over 1, down 2. Over 1, down 6 is actually just right here. I didn't actually mess that up. I just counted wrong there. And so this time we got lucky and my intercepts were right here at -5 and at -1. Now keep in mind, I just said sometimes we get lucky and sometimes we don't, but if we didn't, we would just set 0 to it. Move the 8 across. Divide both sides by 2. Running out of room here. Let's take the square root of both sides. X plus 3 is plus or minus 2. And then when you add the 3 or subtract the 3 from both sides, these are the two answers you would get. But if it was not nice, we would still get the answers very dependably this way. Now, as it turns out, this one is slightly narrow because, again, it's going over 1, not down 1, but down 2, which actually shrinks it a little bit. This thing actually has a maximum value because it has a peak right here. What is that maximum value? It's kind of funny. The maximum value is 8. And then the standard form is a little bit harder. Now, the standard form says, let's take this thing right here and let's rewrite it. So if we looked at this and thought about what it was prior to completion of the square, remember, we cut in half and square, and something cut in half was 3, so that something had to be 6, and square was 9. Now, keep in mind, this was already a completed square, so I don't need to add 9 to both sides. Effectively, that already happened in the cleanup. And so what I have then is my standard form has -2x squared, -12x, and then we got to be careful here because I got a -18 and another -8 for a total of -26. Which is my y-intercept. So you'll see it's coming down very, very steeply. It's not going to hit way until way down here at -26. And then our last question, a blustery day in San Francisco. Raquel is doing some surveying to find the dimensions of the skyscraper. Buildings are too tall for her to measure using the devices that she has at her disposal. This is a long question of a lot of things going on. So let me grab my notes so that I don't just have to sit and read it in front of you. I can't find my notes. It's just going to take me a second because I have a couple of different copies. So here we go. I found it. One more second. I just have to do that. So Raquel is here. She decides to look down at a mirror and see some building over here like this. And so not trying to draw it to scale, but we know that in the physics that the angle that your view hits the mirror and the angle that it exits the mirror have to be the same. That's just sort of a nice little rule. So if Raquel is right here, and she knows that she is not exactly the tallest person in the world at 4.75. She places the mirror 5 feet away from her. And she also knows that the distance from the mirror to the building is 1,052 feet. And so all we have to do is set up that the ratio of Raquel to the distance to the mirror is the same as the building's height is to the mirror. Which means if we just cross multiply, you get 5x equals, let's see, what is that? What is 1,052 multiplied by 4.75. It's a big number, 4997. And I get X is 999.4 feet tall. So a nice tall building. Notice right here, see how this is just a tiny bit further than her length, which means this should be a little teeny bit shorter than that length as well. So that seems plausible right there. And then of course, the silly question is, would Raquel's method work with the same scriber if she was forced to place the mirror closer to the base? Well, it absolutely would work, but if Raquel had to place the mirror closer to the base in order to keep these two values exactly the same, Raquel herself would have to get closer to the mirror. So 100% this would work. You could shrink this number down and this number down and get exactly the same thing. You would just have much steeper angles coming into the mirror and leaving the mirror. So I would say that the method would work for any distance that she wants to do, as long as she positions the mirror proportionally closer to the building. And that finishes our final exam review. So hopefully that wasn't too painful. I'll see you at your final.